We look at an example of using Fermat Little Theorem. Here we want to prove a fact. There are infinitely many integer n such that n divides 4 to the nth power minus n-1024. If you want, pause the video, try to prove. Now, whenever you get stuck with this sort of proof, at least you can try to find n that the statement is true. Alright, so it's even better if you can use Python program or other programs to make the calculation easier. Notice that there are a lot of multiple 5s, looks like. So I try to enumerate all the small integers from 1, 2, 3, 4, all satisfy this condition here and divides 4 to the nth power minus n-1024. Notice that highly frequent that this multiple of 5. Okay, in fact, that would give you a clue about the proof. Okay, here we go. So let's review what's Fermat Little Theorem. So here we have integer a and p. P is a prime, positive prime. We claim that a to the p's power is congruent to a mod p. Now here we consider all the integer that is 5p, p is odd prime. We assume p is not equal to 5. Okay, you're going to see why in a minute. Now with that, let's try to apply the Fermat Little Theorem. Okay, we are interested in the 4 to the nth power, which is in this case with 4 to the 5th power and then raised to the p's power. And if we treat a equal 4 to the 5th power, apply the theorem here, you're going to know that that's congruent to 4 to the 5th power. That's nothing but n-1024, right? 2 to the 10th power is n-1024. So which means 4 to the nth power minus n-1024 is going to be a multiple of p, right? So it's congruent to 0 here, right? That's the result we have. Let's recap here. When n is 5p, where p is odd prime not equal to 5, we have 4 to the nth power minus n-1024 is congruent to 0. That is, this quantity here is a multiple of p. Now we want to prove is a multiple of n, which is 5p. So we need to prove is multiple of 5. How do we do that? In modulus 5, 4 is congruent to -1. And n-1024 is 1 of n-1025, which is a multiple of 5. So it's also congruent to -1. Let's go. So here is -1 to the nth power minus -1 mod 5. Since n is odd, because it's odd prime times 5, that's an odd number here. So this quantity here is going to be -1 minus -1, that's 0. That is also a multiple of 5. Now since p is a prime, and this quantity here is both 5 and p, where p is not equal to 5, we know that it must be a multiple of 5p, that is n, multiple of n. That is, we have proven that with this, by applying the Fermat Little Theorem and by considering the mod 5 arithmetics, we know that this is true for n equal 5p, and of course there are infinitely many odd primes, yeah, for the p not equal to 5, so we can find infinitely many n for this condition to hold. That's a proof. That's an example of using Fermat Little Theorem. Hope you like the video. Please like, share, and subscribe to the channel.